Okay, hi everyone. Welcome to the ecoMotion info session. My name is Faizan and I'm the team lead for ecoMotion this year. I'm in my 4th year of mechanical engineering, and I'll just be giving you a brief overview of how ecoMotion functions and how we are as a team. Sam, next slide. This is just a brief table of contents. Next slide. Okay, some background information on ecoMotion. We were founded in 2016. We're dedicated to designing and competing an ultra-efficient vehicle. We are very passionate about reducing energy loss and coming up with different ways to use the least amount of energy as possible in our cars. We strive to set the bar for dynamic problem solving and facilitating leadership growth. Next slide. And here I'll just go over some brief team history. This was our first year in 2016 and to 2017. This was our second year from 2017 to 2018. And this was our third year, 2018 to 2019. We would also have a fourth year, but last year we didn't get to go to competition because it was canceled due to COVID. Our team vision is we're here to learn new things. We're here to design, build, and test a car, obviously. We're here to have new learning experiences. And all of this is to acquire skills to become a better engineer. And now I'll go over the competition briefly. So this was a competition during our third year, and this is all the teams in Canada. Next slide. Next slide. So the Shell Eco Marathon's objective is to design and build the most energy efficient electric vehicle. Efficient vehicle. There's different categories. Sorry. And there's a Drivers World Championship, which takes the top 3 competitors in America, and then they compete against other teams from Asia and Europe. That happens in London, and that the championship demands the best in vehicle innovation and automotive technology. And so, as I mentioned before, there's different vehicle classes and energy categories. So there's 3 different energy categories, which are internal combustion, battery electric, and hydrogen fuel cell, all of which their goal is to create the most efficient vehicle. And there's 2 categories, prototype and urban concept. So you can see on the image to the left is a prototype vehicle where you're pretty much free to go wild with ideas. And urban concept is, I'll explain that more on the next slide. So in urban concept, the vehicle has to mimic a current passenger vehicle. So it has to have windshield wipers, it has to have stop and go driving, headlights, anything basically you can imagine a modern day car would have. That's what an urban concept vehicle needs to have. So I just wanted to give everyone a overview of how our shop space looks like. So this is how our shop space looks like when we are doing work in there. Right now, it's not possible to go in there. No student is allowed in there, and most of the faculty isn't allowed in the engineering building either. Next slide. So now I'll go over some brief project management and how our team functions. So our typical timeline looks like this, where we have phase 1 from September to October, where we do a recruitment. We have a design phase, design submission, sponsorship and fundraising, and an internal design review, where we basically invite alumni and profs and we show them what we have been doing for the past few months, and they give us feedback on it. And then in phase 2, we have a design freeze, which basically entails we stopped making any modifications to our designs to get ready for assembly. So we have phase 2 is when our construction begins, and phase 3 we have assembly, final construction, and testing of the vehicle. Finally, in phase 4 we have competition. So since all of that isn't going to be possible this year, we've spread apart our timeline into a COVID timeline where we will spend September to April working on 2 new designs. We will be creating a brand new prototype vehicle and basically fixing / creating a new urban concept vehicle. So we'll be creating a new body, new drive system, new motor controller. So we'll technically be fixing it, but it'll almost be a brand new car. So in the summer, we hope to begin work on body, preliminary construction, have our design review, and then hopefully by next year we can spend the entire year just assembling the vehicle. And this will be great for us as we'll have lots of time to design and build. We won't be super crammed this year to closer to competition where when we usually do all of our construction. Next slide. So our team structure looks like this currently. So as I said before, I'm Faizan. I'm the team lead. We have 2 faculty advisors, Randy and Nish. Our mechanical lead is Andrew Bowman and Wesley. You'll hear from more from them later. Our electrical lead is Gabriel, who you'll also hear from, and our controls lead is Samuel, who you'll also hear from. Our safety lead is Nick, and our communications lead is Julissa. And this is our ecoMotion is split up into 3 different sections. So it's split up into mechanical, electrical, and controls. Although electrical and controls are trying to almost work a lot closer together this year. Next slide. And now Andrew and Wesley will go over the mechanical section.
Hi everyone. I am Andrew Bowman. And Wesley will speak a little later on the second half of the mechanical section. And yeah, I was just going to say...
I don't know if you're talking. You can't. I can't hear you. I'm not sure if the rest of everybody else can.
I can hear you.
You can hear me?
Yes, you can.
Okay.
It's just on my end.
It's just a phase-on problem.
I'll fix it.
Yeah, I was just going to say that we'll have time for questions at the very end. We're not ignoring your question there. So starting off with the organization of the mechanical section, we've got 4 main integration sections that help to keep our car organized when we're even just saving files of it. So first we've got the drive section, which is everything from the output shaft of the electric motor to the wheels. And whether that is a gearbox or a chain drive or a belt drive, whatever the designers choose to do with that, that's what we consider the drive section. Our next section is the body. So that's the shell of the car. They are responsible for all of the aerodynamics and how the car looks and making sure the driver can see out of the cockpit and see around them enough for the competition rules, that sort of thing. And it should be noted that this section is not a very heavy stress analysis section. That would be the frame. The body of our cars in the past and likely in the future don't really take any of the load. We don't run, advanced monocoque designs like, say, a Formula One team or SAE, even if they're getting brave, would try. We prefer to use a frame. And so the frame section takes all of the loads on the car and makes sure that the vehicle can handle it. And they also deal with mounting many things. So mounting the body to the frame, they have to make sure they've got tabs for that. Make sure there are axles for every wheel. These seem like obvious things, but they can get overlooked when you're making something as complicated as these vehicles. And then our final integration section is wheels, steering, and brakes, or Wasabi as we abbreviate it. And these 3 seem like they might be separate sections, but they're so closely linked together that we treat it as one big integration section. And so obviously wheels, that's your tires and your rims and any, speccing out axles, that sort of thing. Steering is any mechanism for turning the wheels as well as the steering wheel and what goes on there, what buttons you're including, that sort of thing. And then the brakes, they stop the car, so they have to make sure the calipers and the brake rotors get mounted properly and that there's proper hydraulics running throughout the car, that sort of thing. Sam, can I get the next? Thank you. So as Faison mentioned, there's a lot of work to be done in the coming year or years. On our old vehicle, as he mentioned, our body is falling apart. And even though that picture on the left looks real pretty, it's actually about as aerodynamic as a pickup truck. So we're going to scrap that design and remake one so that it's hopefully more aerodynamic, better to get in and out of, better to work with, and it holds together better. We also have to replace our entire wheels section on the urban concept vehicle because Shell changed the rules on us and our current ones just don't fit those rules. So they all need to be sold off and replaced with compliant wheels and tires. And finally, again, as Faison mentioned, we're building an entirely new prototype vehicle. It'll hopefully be heavily influenced by our previous designs because they worked fairly well, and that makes a lot less work for everyone. However, these are going to be original parts, original designs that you guys are going to hopefully be able to make. So that means everything from the body to the frame to the brakes, everything has to be brand new, essentially, with maybe design cues from the old vehicles. And that's going to take up a lot of work. So now I'll pass it off to Wesley for what you can learn as a member.
Hey, everybody. So, yeah, there's a lot of stuff you can learn from joining ecoMotion. If you're on the mechanical side, this is the things you'll be learning. So, analysis and FAE. FAE is finite element analysis. So that's learning about, forces in what materials can withstand. Stuff like that. I could get into it, but mainly it's just, what you'd make your parts out of. Design for X, you're going to learn how to design things, which is like the coolest part about joining a team is like designing your own stuff and putting it on a car. Aerodynamics and CFD in the top left, that's our current car. And CFD is computational fluid dynamics. You learn how to use SolidWorks and other CAD modeling and drawings there too. So I don't know if you know this, but if by joining the team, you'll get your SolidWorks with your payment. And that's pretty cool, is learning that kind of stuff. It sounds kind of crazy, but it's really not once you get the hang of it. Composites manufacturing. Andy put it in a good term, but it's generally just how Andy, help me out here.
Sorry, I'm trying to think of how I put it, but basically it's learning how you make something out of a composite, because it's very different to making something out of, say, metal or plastic, and why you make it that way. And I think when you're actually manufacturing composites, it helps you to understand that a lot, whereas just looking at a 3D model, say.
And then my favorite part is just getting your hands on stuff, metalworking, and how to work with the tools in the shop and putting everything together.
All right, we can pass it on to electrical now.
All right, so hi everyone, I'm Samuel. Gabriel would normally be joining me today, but unfortunately he couldn't make it today, so I'll be presenting his stuff as well. But just like a little brief introduction about who I am. I'm Samuel, I'm a 5th year computer engineering student, and I've been on the team for 3 years so far. This will be my 4th year. Last year I was a team lead, and so this year I'm taking a little bit of a step back and I'll be the propulsion controls lead, which basically means I'll be leading all things computer engineering. And then Gabriel, who couldn't join us today, he's a 4th year electrical engineering student and he'll be the electricals lead. So we'll talk a little bit about what you can look forward to if you were to join the team as far as the electrical and computer side goes. So there's about 6 different main topics that we'll be, I guess, diving into. There's an autonomous programming competition, which Shell introduced this year. And then there's about 5 other different kind of sections of the car, the battery, the electric motor, wire harness, telemetry, and controls. So the wire harness, this is pretty much exactly what it sounds like. It's wires. This is something that we need to do this year. You can kind of think about it as like the nerves of the car. It's what connects everything together. And so if you don't plan this out properly, it can be a mess, which is kind of what we had encountered in our previous years. So this is one of the things that we'll be doing this year, is planning this out so that way it's not a mess. Another section in the electrical is battery. So in previous years, we just bought our batteries. However, this year we want to go ahead and make our own. The reason for this is that electrical motor requirements typically require a lot of power, and it's really hard to find batteries that you can buy that meet those power requirements. However, it is possible to make your own batteries, and this is typically done by buying fuel cells and combining them. You also need a battery management system for that, though, to detect if any cells are not working properly. And so this is kind of something that we want to do these upcoming years. And so if you're in electrical and that sounds interesting to you, that's something that you can look forward to. And then finally, there's also the motor. So this is kind of 2 sections in a way. There's the motor and there's the motor controller. And so we typically use electric motors for our car since it is an electric vehicle competition, or at least we compete in the electric vehicle categories. In the bottom left there, you can see what a typical electric motor looks like that we've used in the past. Above it, you can see what a motor controller looks like. And so we need to design both of these things. We'll be using Circuit Maker, which is basically a PCB design software that is entirely cloud-based. So it works kind of perfectly considering that everything is remote this year. But yeah, if that sounds interesting to you, that's another section that will require a bit of work, and you can learn a ton of cool things. And so I'll be talking a little bit more about the control side of stuff, which is what I will be leading this year. So there's the autonomous programming competition. This is something that is new this year. Shell introduced it a little bit last year. However, they only gave us a month to work on it. So I'm hoping that this year we can actually compete. Basically what it is it's an entirely virtual autonomous programming competition where you're given basically a stack of software that you can use to design an algorithm that can drive a car on its own. So we're given the robot operating system and a couple other software tools that they haven't announced yet. And so I'm hoping that we can use machine learning and neural networks to design an autonomous vehicle model. So if you're in computer engineering and you kind of like software, this is something that is definitely would be right up your alley. And yeah, so next I'll be talking about the dashboard and telemetry. This is a section that's been on the team for a couple years now. Especially the dashboard is something that we haven't been able to successfully install in the 3 years, or I guess 4 years now that the team has existed. So it may sound a little bit easy, but there's actually a little bit more to it. The most tricky thing would actually be the speedometer. So that's something that we want to get done this year. What ends up happening, I guess, in previous years is that there's a lot of noise that comes from electric motors, and this can make it hard to get accurate readouts. So if this is a problem that you think would be interesting to solve, definitely feel free to join our team. We also want to include telemetry as part of that dashboard. So there's a couple ways that we could take this section. Telemetry is basically just kind of measuring different components and like your power. You can measure your power, temperature, stuff like that. It's pretty much just sensors all over the car. And so what I want to do, at least in this section, is be able to have the driver see that information on a dashboard and potentially even get like an app going where you can connect your phone to the car to get that information without having to unplug anything. So there's room for app development. There's a lot of low-level stuff and embedded systems, as well as manufacturing the dashboard and programming. So if any of that sounds interesting, then I'd definitely recommend joining the team and giving that a try. Just a little bit of going into a little bit more detail about how the electrical section will be run is we're going to go for a kind of a task-based, I guess, system. So if any of these kind of topics interest you, you can just kind of self-assign yourself to those tasks, and we'll be letting you know what the next steps are. and there's kind of freedom to do whatever you want in the team. So I'll be passing it back to Faizan so we can talk about how to join ecoMotion.
Yeah, okay, next slide. So why even join ecoMotion? You get real life experience that you would never get in class. It looks really good on a resume for co-op jobs. It keeps you sane with school, and it helps you meet friends. And we're also an electric car company, electric car team, so we're helping the world and the future. So your commitment level, the more you show up, the more you learn. We don't have a fixed number of hours per week. We know that school comes first, and we do work both on weekends and weekdays, and we had the late night work sessions that was closer to comp. And another great reason is friendships. So the more you commit, the more I think you'll build friends and more chances to do stuff. Next slide. And so in the past, the competition has taken place in California, and it usually takes place in one location for 3 years. And we have an aim to take 50 new and 50% old members and 50% new members. It takes place in April. And since the last competition got canceled, we don't know if it'll be taking place in California again or not. But if it is, you can definitely look forward to going. If you're because I know I got to go in my first year and I was very committed. So that was one of the reasons I got to go. And how to join. So we'll be having our first team meeting next week on September 28th. You can join using the link I will send in the chat soon. And if you noticed that we were missing 3 executive roles, sponsorship lead, treasurer, and secretary. So if you're interested in applying for those, I will also send the link to that as well, and I'll send a application package that will show a brief description on what each of these roles will entail. Next slide. And now we'll take any questions if you have any.
So I guess I'll answer that the question from earlier about why we create a new car every year. We're not necessarily making a brand new car every year, but we try to give enough work to justify existing and justify having members. And so in previous years, that has been a whole new car. This year, it is again. So that's just kind of our reasoning for that. For cost to join, it's $40. That gets you SolidWorks license and potentially other software that we're working on, as well as usually a team shirt and some expenses, but we're not sure how that's going to work this year specifically. Let's see. So for